Okay, today is day one of section 4.5, which is U substitution. We've been working on area between two curves, or area-related problems, for the last several weeks. We're going away from that for the next few weeks, and we are going to be learning some more advanced integration techniques. We've been pretty technology dependent in terms of answering questions. With this section and the next few sections that we do, it's going to be more paper pencil algebra/calculus skills. So for the first example here, we want to integrate x to the fourth plus 5 quantity cubed times 4x to the third dx. Now, based on what we know prior to this lesson, in order to integrate this, what we'd have to do is take this, cube it out, either using foiling again, or maybe using Sierpinski's triangle as a shortcut. Then once we have that multiplied out, then we'd multiply through by 4x to the third, and then we'd have a rather large polynomial that we could use the power rule on. Now, in certain situations, that may be the only option in terms of getting it integrated. But we're going to focus for the next few days on something called U substitution. What we're going to do is take part of what we're trying to integrate, substitute it with a simpler expression, namely a U, and then that will allow us to be able to integrate it using some other rule that would be simpler than what I just explained to you. Now, the key here, or one of the keys here, is to be able to choose a good U. You want to choose a U such that when you take the derivative of it, it appears somewhere else in what you're trying to integrate. So what I mean by that is if we let U be x to the fourth plus 5, the derivative of that is 4x to the third, which appears there. So that would lend us to believe that that's probably going to be a pretty good choice to get this integrated by that technique. So you are going to choose what you want your U to be. In this case, the one that I think is going to work the best is the x to the fourth plus 5. We're going to take its derivative with respect to x. So that becomes du dx. That's basic power rule, 4x to the third. Now, for the purposes of what we're going to try to accomplish over the next couple weeks, we're going to want to express that a different way. We're going to bring that dx over here, and we're going to rewrite that as du is equal to 4x to the third dx. All right, now we're going to use this information in order to make a substitution. So this thing here that we let be our u, x to the fourth plus 5, that's being raised to the third power. So I'm going to replace that x to the fourth plus 5 to the third with u to the third. And then that 4x to the third dx gets replaced with du. And now we have a significantly simpler thing to integrate here. That's basic straight up power rule. So exponent goes up by 1, divide by the new exponent, plus our constant of integration. And then we back substitute and replace u with that x to the fourth plus 5 from the first step. Now, there aren't a whole lot of options in terms of how to express this. Maybe 1/4 out in front rather than divided by 4. But the same as all the other derivative and integration stuff we've done throughout the course, many of these have many different ways you could express it. In a free response, as long as it's reasonably simplified, it would be acceptable. In terms of checking your answer in the back of the book, you need to be able to rewrite it into a form to determine whether it's correct or not. For the purposes of multiple choice, you need to be able to rewrite it to choose the correct option. All right, second example. We're integrating 3x squared over the square root of x to the third plus 9 with respect to x. Okay, based on the math we know prior to today, that's something that I'm pretty sure will be unable to integrate. Now, applying what we did up top here, we're going to look to see what would be a good u. Well, one thing to consider would be, well, what if u is 3x squared? Well, then du would be 6x. 6x doesn't appear anywhere else in there, so that wouldn't be a good choice. If we let u be x to the third plus 9, du dx would be 3x squared, which appears up top. So that's an indicator it's probably going to be a good choice. So if I let my u be x to the third plus 9, which is that piece that's inside the radical on the bottom of the fraction, that makes my du dx equal to 3x squared. And then for the purposes of what we're going to be doing for the next couple of weeks, we want to write that, bringing the dx over to this side. Du is equal to 3x squared dx. All right, now we can do our substitution. So that x to the third plus 9, that's the bottom of the fraction that's being square rooted. I'm going to want to rewrite that to the 1/2 power to make it easier to integrate. And then that entire 3x squared up top combination with the dx, I replace with du. So I'm going to put the du out here and a 1 up top, makes it cleaner to do the integration step. One more move in order to make it easy to integrate. I'm going to rewrite u to the 1/2 on the bottom of the fraction as u to the negative 1/2 up top. Now with straight up power rule, exponent goes up by 1, divide by the new exponent. Dividing by 1/2 is the same as multiplying by 2. Substitute that x to the third plus 9 back in for the u, and that's being raised to the 1/2 power. This answer right here is 100% perfectly acceptable. Chances are, if the original problem was given to you in radical form, the answer, like if you check it in the back of the book or as a multiple choice problem, is probably going to be in radical form, but there's nothing wrong with leaving it like that. All right, next example here. What happens when you're using u substitution is it's relatively common that when you choose that u and you go to do the substitution, the constant is off a little bit. So I'm going to go through a couple of examples of adjusting for the constant not quite lining up exactly as it should. So one option we could do here, and this wouldn't actually be too bad, is you could clear those parentheses and just use regular power rule, and there'd be nothing wrong with that. That would be perfectly acceptable. But using the u substitution, which is what we're focusing on today, if we let the u be 3x squared, du would be 6x. Well, that doesn't appear anywhere in here, so that's not a very good choice. If we let u be 2x to the third plus 5, that means du would be 6x squared dx. That just misses. We have a 3x squared. This is going to be a 6x squared. So we're only off by the constant. So here's one way we can deal with it. We're going to let u be 2x to the third plus 5. That makes du 6x squared dx. And for this one, I already brought that dx over to the other side. Now what I'm going to do is I'm now going to divide both sides by the 6. So I'm going to have just the variable x squared dx. So that's going to ultimately go in here, x squared dx, and the 1/6. I'll show you what we're going to do with that in a minute. So my personal preference, it's not the only way to do it, but when these constants don't line up, I like to get them all to the outside. So what I'm going to do is I'm going to take that 3 and put it out in front like this. The 2x to the third plus 5 stays here. I'm going to put the x squared there, dx, just to make the substitution step a little bit easier to visualize. So, the 3, just coming along for the ride as constants always do. 2x to the third plus 5, that's my u. The x squared dx, I'm replacing with 1/6 du. And as I said, I like to get all the constants to the outside when I deal with this. So the 3 was already there. Bring the constant to the outside. U du is what we're left to integrate. So cleaning this up a little bit, 3 times the 6th is a half. Half comes along for the ride. Exponent goes up by 1, divide by the new exponent, plus our constant of integration. So the 1/2 times that 2 on the bottom is 1/4. U squared plus c. And then we substitute to get back in terms of x. So we have the 1/4 u, off the screen a little bit here, That was my 2x to the third plus 5. That gets squared, and then plus c. And another common way you would see this is the whole thing over 4, or you could leave it like that. Either one is fine. All right, one more example of dealing with integration by u substitution when the constants don't quite line up. So considering our options prior to what we learned today, if we were to get this thing integrated, we have to take this trinomial, raise that to the 4th power, which would be quite a task in and of itself, and then we'd have to take that and multiply it by x plus 1. So this would be an absolute monster if we tried to attack this using strategies prior to knowing u substitution. All right, now on to the u substitution. The two candidates would be, we want u to be x plus 1, or we want u to be x squared plus 2x minus 3. Well, if we let u be x plus 1, the u dx is just 1. That doesn't really seem to do us a whole lot of good. If we let u be x squared plus 2x minus 3, the du dx is 2x plus 2. Now 2x plus 2 is almost like that. It's only off by a constant, so it's probably going to end up working. So I'm going to let my u be x squared plus 2x minus 3. That makes my du 2x plus 2, and then I brought the dx over here from underneath like I did for the last problem. And then now I'm going to recognize that this is just 2 of those. So I can factor out that 2 and then divide by the 2 to get 1/2 du is equal to x plus 1 dx. Now that is a nice, clean, fast, easy substitution to make. So this is my u. That whole thing was raised to the 4th power. So I have u to the 4th rather. This is getting replaced with 1/2 du. I like to get my constant out in front like that. Basic power rule now. Exponent goes up by 1. Oops. Looks like I forgot to do a step here. Divide by the new exponent. So that's going to make this 1/10. Fix that. Substitute in my x squared plus 2x minus 3 back in for the u. That's being raised to the 5th power, and then we have our constant of integration, the plus c. So that's a pretty good overview of the basic skill set you're going to need for the first round of problems with this. And then what we're going to do is build upon this literally for the next couple weeks in terms of adding in different variations and different possibilities of how to consider what the u is going to be.